Okay, I will continue to explain the algorithm for sub-goal data construction. First, to load the map, and it's the number of sub-goals. The best sub-goal between S prime start and S prime goal is defined as the farthest state along an optimal path from S prime start to S prime goal, which is still reachable from S prime start via simple hill climbing. The line 3 creates creates a random pair of states throughout the subgoals, which means that now we have n pair of states. States in each pair should be close enough to reach, but at least 2 moves away each other. Using the pairs, find an optimal path with a star from the third state to the last state. So from the third state to the last state, along with the optimal path towards subgoals that is reachable from S prime start with hill climbing. I think not here, it should be deleted because we are collecting at subgoals that is hill climbing reachable from S prime start. The implementation approach uses k nearest neighbors, k and n, to select subgoals in the database. The paper set k to 1, which means the algorithm finds one nearest node from the current node. Then how to decide the nearest node? The line 4 shows that the algorithm chooses the nearest subgoal on the basis of the similarity in heuristic distance from S start to S prime start and from S prime goal to S goal. In other words, the algorithm scans a pair of S prime start, S prime goal, S prime subgoal, and locate the S prime subgoal such that heuristic distance between S start and S prime start is the most similar to the distance between S prime goal and S goal. What I mean by this is S start, which is the actual start, and S goal is the actual goal. And S prime start and S prime goal is the abstract pair of start and goal node. And the similarity computes this distance and this distance. And if the distance is similar, then we are going to choose that pair. And the heuristic distance in this case is Oxtail distance. However, Oxtail distance does not consider obstacles in the way. Line 5 addresses how to solve the issue when an agent faces obstacles. Choose the next best subgoal if both S prime start and S prime goal are not reachable from the start and the end node respectively. The line 3 specifies that the algorithm searches the database only if S goal is not reachable from the actual start. If they are near enough to generate an optimal path, then it is not necessarily to move along with subgoals. To prevent revisit of the same nodes, line 8 sets a taboo list to exclude nodes already visited. Overall, the algorithm only runs m times to reduce the time complexity. So this is the m times to reduce the time complexity. In the evaluation section, the authors ran the LRTA here and KNN LRTA star in 8 maps from 2 popular games, which are Baldur's Gate and Warcraft 3. This table compares the performance of 2 algorithms in terms of time, size, suboptimality, and the number of states per move. Suboptimality means a percentage compared to the optimal path. If a path costs 150, its suboptimality is 50 when the cost of the optimal path is 100. As shown in the table, the modified LTRA stars produce more optimal paths considering the size of the map. I'm talking about here. And however, the reachability checks of KNN LTRA stars causes longer duration of the time to compute. So you can check the time over here. And but the authors encouraged to use KNN LTRA star in the exchange of the disadvantage because KNN LTRS star's computation time, this one, will not be completely the worst case, and memory saving is vital in video game hardware. And lastly, they provide some future works. How can we enhance the performance of KNN real-time A-star search? In the subgoal data construction, the algorithm chooses pairs of S-start, S-prime goal, S-prime subgoal randomly. The algorithm can be improved if the pairs are selected in a reasonable way. Next, as mentioned, Oxtel heuristic distance excludes obstacles in paths. They suggested the improvement in the algorithm so that it computes similarity as well as obstacles. Additionally, they initially set k to 1. If k becomes larger than 1, the enhanced algorithm could find another optimal path. In conclusion, the 2 papers we have summarized are about real-time A-star search algorithms, LRTA star. One is the modified LRTAs used in air vehicle path planning, and the other is modified VLRTA star used in optimal path planning for video game agents. NI LRTA aims at improving running time of the classic LRTA star, and KNN LRTA star seeks to save substantial memory usage of subgoals database. Yeah, so this is our presentation video of group 8.